Welcome to Solar Radiation Fundamentals for Solar Photovoltaic Systems, Part 2, which covers the effects of the Earth's movement and atmospheric conditions on the solar energy received on the Earth's surface. The Earth's movement and changing angles between a surface on Earth and the Sun's rays affect the amount of solar radiation received at any time of day a year. Two major motions of the Earth affect the solar radiation received on a surface at any location. The first is the rotation of the Earth about its polar axis, defining a day, and the orbit of the Earth around the Sun, which defines a year. The amount of solar radiation received at any location on Earth depends on the time of day and year, the local latitude, and the orientation of the surface receiving the Sun. Also, it is significantly affected by local weather conditions. The Earth's tilt is 23.5 degrees and does not change. However, the angle between the Earth's equatorial plane and the Sun's rays changes constantly. The Earth's polar rotational axis is tilted at a constant 23.5 degrees with respect to the ecliptic plane. During its annual orbit around the Sun, the Earth's pole's axis is never perpendicular to the ecliptic plane, but is always inclined at an angle of 23.5 degrees. This results in a constantly varying angle between the Earth's equatorial plane and the ecliptic plane as the Earth orbits around the Sun over a year. Except at the equinoxes, the Earth's axis is tilted away, or either towards or away from the Sun, causing the change in seasons. Solar declination is the constantly changing angle between the Earth's equatorial plane and the Sun's rays, varying between minus 23.5 degrees and plus 23.5 degrees. And this takes place in a sinusoidal fashion. The solstices. The solstices define the points in Earth's orbit around the Sun having the maximum and minimum solar declination. The solstices occur when the Earth's axis is inclined at the greatest angle either towards or away from the Sun, and define the annual range of the Sun's position relative to any point on Earth. The equinoxes define the 2 points in the Earth's orbit around the Sun having zero solar declination. On the equinoxes, the Earth's axis is neither tilted towards or away from the Sun's rays, but is perpendicular. The Sun rises and sets due east and west respectively, and days and nights are of equal length, 12 hours everywhere on Earth. The Sun is directly overhead at solar noon on the equator at zenith. The winter solstice occurs on December the 21st or 22nd, when solar declination is at its minimum, minus 23.5 degrees, and the northern hemisphere is tilted away from the Sun's rays. The vernal equinox occurs on March the 20th or 21st. Days become longer than nights in northern hemisphere for the next 6 months. 6 months later we have the summer solstice, which occurs on June the 21st or 22nd, when solar declination is at its maximum, 23.5 degrees, and the northern hemisphere is tilted towards the Sun. The autumnal equinox occurs in September the 22nd or 23rd, and days become shorter than nights in the northern hemisphere. This is the end of part 2 of 3. Complete the quiz for this part and then continue on to part 3.